Do you know if you cut a cone laterally into two, you'll be forming another three-dimensional object, which is not a cone. That object is what we call the frustum of a cone. I believe you've seen the shape of a bucket, how the top is open up, the down is closed down. That is an example of a frustum of what? A cone. So how do we find the various size in terms of volume and that of the surface area? Come with me, let's delve into that in this tutorial. So this is what we are having. So this is the cone, the original cone that has been cut horizontally. When you cut it horizontally and that cutting is parallel to the base. So you can see you put a horizontal plane and we cut it into two. When you lift it up, you will still see a cone. So this will be the truncated cone, or the cone that is sliced off. So when you slice off this, you'll be left with the base. You can see this. So the base is what we are calling the frustum of a cone, or better still, we can call it the truncated cone. This is the truncated. So the cone that has been truncated, whereby the top part is taken away. All right, let's dissect the various parts. Now you will see that on this whole cone, from the top here down to this place, let's use V here and use O here, all the way to this place, you'll be seeing a height, which is the height of the cone. Then when it is cut off, the top will also be producing a height. So let's say this is the height, we use H, and this very height we can use capital H. Then you see that the radius of the cone, the original cone, becomes the radius of the frustum, which we can use capital R to indicate that. Then as we cut off this is going to produce a cone with a different base, and that base will also have a radius. That radius, since it is cut from the same place, they will have the same cross-sectional area, so therefore this also be R. So the radius of the top base of the truncated cone is the same as the radius of the slice off cone. I believe you get it. There are two terms they're using. Slice off, then truncated. They are all cone from the original stage. All right. Then we can also say that the whole of here, let's label here to be A, B. If I increase the line, it will be C, D. Okay, let's use here to be, let's say P and O. All right. I think when I label it there, I can still have it on this as. All right, so now let's see how we are going to dismantle this. Now, if you look at this carefully, you can see that the height of the cone is cut off from the height of the original cone. I mean, the slice of cone is cut off from here. So if I'm looking for this height, it means the total height minus the truncated one will give me the slice of one. If I'm looking for the slice of one, I'll also have to subtract this from the original to get this, subtract this from the original to get this. All right, what again can we find? We can see that if I bring down this line, which is going to be perpendicular, this line will be perpendicular to the radius. If it is perpendicular, then from the center to that line will be the same as from here to here. That will give us the radius in terms of small r. So this small portion here, which is perpendicular, if I cut it off, is going to be here. Let's use that as slant height. Let's use L here. So this area is going to be the original radius, which is R capital, minus the cut-off place. So here become R minus what? Small r. Then we have here to be h. So if I'm looking for the slant height, if I'm asked to find the slant height of the truncated cone, I'm just looking for the truncated cone. I'll be using this as a right angle triangle. Therefore, the slant height of the frustum become S equals to the square root of, this is going to be hypotenuse. So h square then plus r minus small r all square. This can also come before this, since addition is what? Commutative. So this is the first formula we are going to deal with. If in case I am asked to find the slant height of the truncated cone, I may go for this. Now, if I am asked to find the volume, find the surface area, it means that I need to treat this in these three stages. The whole volume minus the volume cut off. Then I'll get a truncated one. So truncated one is always a part that we need to have if we subtract the slice off part from the original cone. That is the stage we are going to deal with. So now we have this formula. We can also deal with the slant height of the slice off. So if I have slant height of the sliced off, is double F, right? Cone. That is going to be L square equals to H square plus what? R square. Meaning that will give us L equals to the square root of H square plus R square. So this is to find the slant height of the slice of cone. This is what we are going to have. So from here, what we need to know is also how do we find the volume? How do we find the volume? So before we develop that, let's see. We can see that total height of cone, when I mean cone, I'm referring to the original cone, is going to be from here to here. And that will be h plus what? H. From here to there. That's the total height. If I'm looking for the total height of the original cone, the truncated cone, which is a frustum, plus the cone that is sliced off, if I add the two, I'll be able to find the total height, right? Good. What again can we find? So we can also see, if I want to find total slant height of the cone, let me just use cone, is going to be the addition of the two. What do we have? We label here to be S. So if I use capital R, L, it will be equals to L plus what? S. The total slant height, which is the VB or the VA, is going to be this place plus this place. What again can we note from here? We can also note that the radius of the cone is going to be R. This is the radius of the cone, which is the R, the same as radius of, okay, let me use frustum direct. The frustum will also give us R. Don't forget, this R is there. What again can we find from there? We can also see that the radius of the slice off, don't forget, we can also call it smaller cone, is going to be R. So these are some of the terms that we are going to be picking from here, if in case we want to develop this into the volume of a cone, which is truncated, or the surface area. in the next episode, we are going to use this concept that we have, the introduction, and move straight into finding the volume of a frustum. Like, share, and comment. Come back to this page for the continuation of this. Bye-bye.